So the LeetCode problem we are going to solve now is one of the most popular LeetCode problems, that is called best time to buy and sell stocks with cooldown. This one is a medium problem, but in my opinion this can be categorized as hard in some scenarios, and this is a very well-liked problem. So let's understand the problem statement. We are given an array called prices that represents the price of any particular stock on any particular given ith day. Now we need to find the maximum profit that we can achieve, and we have the luxury to complete as many transactions as we like, and the only restrictions is that after we sell our stock we cannot buy the stock for the very next day, which means we'll have to cool down for one day. Now let's try to understand this with an example. Say here are the price of any particular stock is given for 5 consecutive days, and our aim is quite simple: maximize the profit. Now let's try to first understand that what is going to be the answer in this case. Let's say if we decide to buy stock on this particular day, then our buying price is going to be 1, and then we decide to sell the stock on this day, so then our selling price is 2. So what is the profit we made during this duration is going to be of value 1. Then remember, after selling we'll have to wait one more day for the cooldown. So let's say that we decide to cool down on this day, then we buy again when the price is 0, and then we sell again when the price is 2. So we make profit of $2 or 2 units over here. So in total amongst these prices the maximum profit we can make is going to be 3. Now notice that we did not use the greedy approach and try to maximize our profit in one single transaction. Why? Because logically it would make sense that if we have values like this, then if we have already bought the stock on this day, then instead of selling over here, if we decide to sell on this particular day, then our profit for this region would have been 2, but this would not yield us to the maximum profit. Why? Because then we cannot buy stock on this day because of the cool down condition that we have, and then we are at the last day. So even if we buy the stock, then we are just diminishing our profit. Let's say that we don't do anything on this day, still the maximum profit we can achieve is going to be 2 in this case. So this is a very tricky problem, and first let's try to understand a very simple brute force approach in this case to solve this problem. Now notice the brute force approach is quite straightforward. We, for any particular day, simply try out all the different combinations and permutations and combinations, and do all sorts of calculation. So we can check that what if we buy on this day, then we decide to sell on this day, then we decide to sell on this day, then we decide to sell on this day, and then we decide to sell on this day. Once again repeat the same scenario where we are buying on this day and then selling on this particular day, and based on that also consider it for the cool down scenario as well. So logically, for any particular ith day we can have 3 different states that we can think about, whether either we are buying, we are selling, or we are resting. And for each one of the 3 possibilities, we'll have to do this ith times, and we are calculating all the permutations, which means now we are talking about the time complexity that yields in big of n factorial time, because we are dealing with all the permutations. So this is a very expensive brute force approach to find the maximum profit. We'll have to optimize the things, but the thing is there is no way for us to get away from maintaining the states for any particular ith day, that what if we buy the stock, what if we sell the stock, or what if we rest for that particular day, and what is going to be the maximum profit in that regard. And once we have this information, it becomes much easy for us to find the appropriate result that we are looking for. Now let's talk about the optimal way that we are going to solve this problem, and we are going to use the most beautiful concept in the computer science, that is dynamic programming. Now let's just do a quick recap. Why do we need to do dynamic programming in this case in order to solve this problem? Well, logically we cannot use just any single approach to find the maximum profit. We just saw it with this example, that if we decide to use greedy approach where we are trying to buy at the smallest price and sell at the highest price, this does not yield the correct result. Also, the decision we make at any particular day on whether we need to buy the stock, sell the stock, or go into the cool down mode would depend on the all the previous values we had, and all the future calculations that we might have, which means all we can do is that for any particular day we can simply say that if, let's say, on this particular day, if I decide to buy the stock, what is going to be the maximum profit I can make. If I decide to sell the stock, what is going to be the maximum profit. And if I decide to go for the cool down, what is going to be the maximum profit. And keep this calculation doing for every single one of these days, and just based on the previous calculations of the previous day, we should be able to calculate the maximum profit of the subsequent day. So I know what I just said might confuse you, but let me explain it with an example. So let's say that for the same example that we were talking about, let's define each of the scenarios for maximum profit that we need to calculate in each of the three scenarios for buying, selling, and for holding or resting, or if we are in the cool down mode. How do we define that what is the maximum profit we can generate if we decide to buy on any particular day? Let's say that on this particular day, if I decide to buy a stock, then what are the different considerations that I'll have to make? Number one consideration is we can only buy any stock after we are coming out from the cooldown, which means on the previous day we must have been in the cooldown state. So number one thing is, we'll, in order to check the maximum profit for buy on any particular day, we will have to compare two values. Number one value is that what was the maximum profit we were achieving on the previous day for this buy operation, and compare it with that what if we did a cool down yesterday and now we are trying to buy. So the cool down maximum profit for the previous day minus the current ith value we have, so price on this particular day. So now let's try to generate the mathematical equation for any particular value of buy. But the thing is, we'll have to remember that what was the maximum profit achieved on the day before, and not on the current day. So for that, we'll need to have some data structure that stores that information, and we can use an array to store that information. We can create an array of the same size. So let's say that I create an array of size 5. Where for any particular day I'm defining that what is going to be the maximum profit I can achieve if I decide to buy on that particular day. So that calculation is going to be dependent on the maximum profit I was able to achieve if I had already bought before and not buy today, or maximum profit I can achieve if I'm coming out of the cooldown and I decide to buy today. So what the mathematical equation is going to be, that maximum profit on if I decide to buy on ith day would be, I'll need to compare two elements. So max between what was the buy of I minus 1. So what was the maximum profit on the previous day, and compare it with the cool down profit on previous day plus, sorry, not plus, but minus the current prices that we are dealing with. So price on the current day. So this is going to be our mathematical equation for our buy formula. Same way for our selling, let's say that if we want to calculate the maximum profit we can make if I decide to sell on any particular ith day. Once again, I'll have to do the calculation with the previously calculated values. But now in this case, the calculation comes off a bit different. Number one thing is, if I decide to sell today and on any particular day, then the profit I'll be comparing it with is that what is the profit I was making if I sold yesterday. So if I sold yesterday and I made more profit, it does not make sense for me to sell it today. So that is number one thing we are comparing. And we are comparing that what was the buy profit that we made yesterday. So if I bought yesterday, what was the maximum profit I was making plus the price of the current particular day. So same way for the buy we made this equation, same way we can make another equation for sell, where we are comparing the maximum value amongst the two values. So what was the previous profit if I sold on yesterday instead of selling it today, and comparing it with what if the maximum profit I made on buy of I minus 1. So previous day if I bought the stock plus whatever the price of I today is, because the price increased, so there is higher potential that I can gain more profit by selling the stock today. And next thing is, if I decide to rest on this particular day. So let's say that instead of selling on any particular day, I decide that I'm not going to do anything and I'm just going to rest. Then what is going to be the implication? So we simply need to compare that what was the previous day's profit we were making, that is for sure. So for rest, we are going to compare the previous day's profit. So rest of I minus 1, and we are going to compare it with what if we sold yesterday. So if we sold yesterday, then we are resting today. So what is going to be the profit if we sell yesterday, and whichever value is maximum, we are going to store that as the answer. Okay, so based on our explanation, these are the three different equations that we made. Now I just wrote them roughly to have a brief idea on what we are talking about. And then we have initialized three different arrays that we are going to play around to keep track of the maximum profit on that particular day based on whether we can buy, sell or rest on any particular day. So now let's first initialize the value, and this is the prices array that we are given, that we are dealing with. Now on first day we cannot sell anything or we cannot rest, so we can mark these values as 0. And the maximum profit we can make on very first day is if we decide to buy something. And let's say if we buy something, we haven't made any profit, we are actually losing money or putting money on the table. So the maximum profit we can make if we buy something is going to be -1, or the negative of the price of that particular day. Okay, now we can start our calculation. So let's say that for second day, if we have to calculate that if we decide to buy something, what is the maximum profit we can make. So for that, for buying, we need to compare the buy price on the previous day, so maximum profit being made on the previous day. And what if we decided to rest on the previous day, so what was the maximum profit we were making then, minus the price of the current day. So if we compare that, we are comparing the value of -1, that is the maximum profit being made on the previous day. And what if we rested on the previous day, so that was 0 minus the price on the current day, so 0 minus 2. So we are comparing the values of -1 and -2. So what is the maximum profit we can make? Well, of course maximum profit is going to be -1, so we can simply mark -1 at the buy array. Same way for the sell array, if we decide to sell on this particular day, what is the maximum profit we can make? Once again, we are comparing the previous selling profit, previous maximum profit from the previous day, or what if the previous maximum profit we are making if we bought a day earlier plus the prices of the day today. So of course this is quite obvious that if we decide to compare, then first value we are comparing is 0, because that is the maximum profit we are making on the previous day, and we are comparing it with the buy maximum profit on the previous day, so that was -1, plus the price is today, so the price is today's 2, so -1 plus 2. So we are comparing the values 0 and 1, so obviously 1 is greater, so maximum profit we can make if we decide to sell is going to be 1, so we'll mark 1. Same way, if we decide to rest today, then we are comparing two values, the previous profit being made on rest and previous profit being made on sell. Both of these are previous because we are simply not doing any transactions, we are just resting, so both are 0. So since this maximum profit we can make by resting today is also going to be 0. Next thing is that what is the maximum profit we can make when the price is 3. So once again, for buying we are comparing the maximum profit, so -1 versus what if we rested, so resting is 0, so 0 minus 3 is going to be -3. So -1 and -3 we are comparing, so -1 is the maximum profit, so we'll just mark -1 so far. Okay, now for selling, if we decide to sell when the prices are 3, we are comparing two values. First value we are comparing is the previous day's profit, so that is 1, and second value we are comparing is the previous day, so this is -1, so -1 plus 3, so that is going to be +2. So once again, and by the way, this, it would not be this -1 but this -1, I just did not included that, but I hope you understood what I mean. So this profit is going to be 2, that if we decide to sell today, maximum profit would be 2, which would be great. And for the resting over here, we will have to compare the previous day's resting value versus selling value. So this is 1 because we are comparing these two values basically. Once again, when the prices are 0, what is the maximum profit we can make? So now the values we are comparing is going to be -1 with what if we decide to rest yesterday. So if we rested yesterday, then we would have made so it would be 1 minus the current day's price 0. So 1 minus 0 is going to be 1. So we are comparing values -1 and 1. So over here obviously the judgment is quite obvious that it would be in our favor to buy today. So we'll just mark as value number 1. Same way, if we decide to sell today, what is going to be the maximum values we are comparing? Number 1 value is previous day's profit, so we'll mark 2. And second value we are comparing is that what if we bought yesterday, so that is going to be -1 plus the prices of today. So -1 plus 0 is going to be -1. So answer is quite obvious that we are just going to leave 2 as it is. This is the maximum profit we can achieve if we decide to sell today. And for the resting phase, if we decide to rest, we are comparing these two values. So maximum profit we can make is going to be 2. Now for the very last day, the value is 1. So if the value is 1, we are comparing these two values. So first value is 1 and second value we are comparing is 2 minus 1. So both values are 1. So we can make maximum profit as 1. So we'll just leave 1 as it is. Next value is, for in terms of selling, what is the maximum profit we can make? So one option we have is 2 because this is what we have. Second option is that the buying profit from the previous day. So this is going to be value 1 plus the price of the stock today. So okay, and this value should not have been 1, this should have been 2. So let me just mark it clear. Okay, so 1 plus 2. So 1 plus 2 is going to be 3. So we are comparing values 2 and 3. So it would be in our favor to sell today if we bought yesterday. So now the answer is going to be 3. This is the maximum profit we can make. And for the very last element, if we decide to rest today, which means we must have sold all of our stocks yesterday. So we are comparing these two values and the values are 2 and 2. So this is going to be 2. Now this is what our table looks like basically, where we can see that in the end we simply need to check that what is the maximum profit we are making if we are selling on the last day or if we are resting on the last day. Because if we buy on the last day, we are always going to lose money. So whatever value is higher amongst these two value has to be our profit, and in this case our profit is going to be 3. So this is what we can return as it is. So this is the whole solution. I know it looks messy, but it's beautiful in my opinion, because we are, imagine what we are doing. For every single day we are maintaining 3 different states. We are calculating that what is the maximum profit we are achieving on each day, and we are taking into the consideration of the previous task being done for any particular day's solution. So that is in itself pretty awesome that we are able to do it. And dynamic programming is actually giving up a huge contribution in this program. So if we see time complexity now, then it is going to be big O of n, because we are simply iterating over the given input array once to solve the whole thing. If we see space complexity, well, this is going to be big O of 3 times n, because we are initializing 3 new arrays to store all of these states. So this is a beautiful time and space complexity, and also an excellent question in my opinion. So I hope the explanation made sense. Now let's see the coding solution. Now the coding solution for this problem is quite straightforward. First of all, we are checking that if the given prices is equal to null, or the given length of the price array is less than or equal to 1, then we can simply return 0. If that is not the case, we have a variable n that is defined to calculate the length of the given prices array. Based on that, we are going to initiate 3 different arrays to check out the state of the profit on every single possible outcome. So first one is for buy, second one is for sell, and third one is for rest. Now we are going to initialize all of these 3 arrays for the very first position. Now for sell and rest, the value is going to be 0, because it's quite straightforward. We cannot sell on the first day, and if there is no sell happening the day before, then we should not be resting, or this should not be a cool down day. But for buying, because if we decide to go and buy on the very first day, then definitely we are going to be at a loss. So the maximum profit would be the negative price of that stock and on that particular day. Now we are simply going to run a for loop to iterate over the given input array. We are starting iterating from the very first day, and now we have our condition set up for buy, sell, and rest. In order to make the judgment call that what is going to be the maximum profit if we decide to buy a stock on any particular day, then we will have to compare that what was the maximum profit if we bought the stock the day before and we need to compare it with, let's say that if we decide to rest the day before minus the current prices on this particular day. Same way, the maximum profit for sell is going to be calculated, where we are comparing the profit from the previous day by selling or by buying whatever we bought on the day before plus the current prices of this day. So we'll compare these two values, whichever is higher we are going to keep that as the profit. And in order to make the judgment that whether we should rest or not today, we will compare the maximum profit achievable on any particular ith day. And for that we are comparing that what if we decide to, what was the profit we made if we rested the day before, comparing with what was the profit we made if we decided to sell the day before. Whichever is higher, we are going to keep it as it is. Now for the maximum profit, we simply need to compare that what was the value if we decide to sell on the very last day or if we decide to rest on the very last day. Whichever one value is higher, we are going to return that as the answer. So this is the whole solution. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully. It beats almost 80% of all the other users, which is pretty significant. And once again, the solution of this code is present in our GitHub repository. So feel free to go ahead and check it out from there. Thank you.